Hi, I'm Kevin, and today I'm going to teach you how to put stuff on a map using WebGL. Let me get my face out of the way, and let's get right into it. We're going to be doing this stuff from scratch, so use any editor that you like, make a folder, and the first thing we need is an index.html. We know we're going to need some styles in here. Not there yet, but it will be soon. And we're going to want a canvas. Eventually, this canvas is going to be a map, so let's go ahead and call it map. Now, let's make our CSS. I always like to put a border on it just so that I can see it. Oop. Let's see what we're looking like now. All right, we've got our canvas. Now our goal for this first part is we just want to put a point on the screen. It's going to be a bit of work, but it's really not that bad. So we are going to need some JavaScript to do this. And the way that I like to do JavaScript is I like including JavaScript in the head. It really doesn't matter. But if you include it in the head, it means you need to wait for the window to load. And I want this to be a module so that I can import stuff if I need to, so I don't have to have one big file. So now let's see if this is working. All right. We've got CSS working, we've got JavaScript working. Now we can actually get started. So the first thing that we're going to want to do is, let's briefly explain what WebGL is and what we're going to be doing. So with your graphics card or whatever you're using for graphics processing, if you're on a Mac and you have, all-in-one, whatever, there's a series of stages that everything goes through. And two that you always have to go through is a vertex processor and a fragment processor. A vertex is a point in space. A fragment is a potential pixel. So you have points in space, you're going to move them around, transform them, turn them into triangles maybe. We're not doing that here. And then you have potential pixels that you're going to want to draw to the screen. So we are going to need a vertex processor. Usually they're called shaders. And we're also going to need a fragment or pixel processor. And we're going to want to compile these programs, link them together so that we can use them. So compile shaders. And we're going to want a graphics context, a vertex source, and a fragment source. So the first thing that we need is we're going to need to create a program. Shaders use a C-like language, so we're not going to be writing JavaScript here. We're going to be writing something akin to C. We're going to need to compile them, link them together to create a program. So the first thing we want to do is we want to create a vertex shader. We're going to set the source of the shader to the source that we pass in, and this is just going to be a string. Oh, I'm going to call this shader source. So we're telling the graphics context, what the source of the shader is that we're going to compile. Then we're going to compile that shader. And then we are going to attach it to our program. And we're going to do the exact same thing for the fragment shader. And then we just want to link the program. And we should be all good, but just in case we make any mistakes, we want to know what those mistakes are. So if the link status is not good, if it's not a truthy value, then we want to print out what went wrong. And then we return the program. So now we want to use this program. So let's get the sources. And you could do this as a string, but because it's a different language, I prefer to have it in a different file. And as these things grow, you probably want them in a different file anyway. And now that we're using async and await, we need to make this an async function. So we want to get the canvas, and from the canvas, we want the WebGL2 context. So 2D, that's if we were going to be doing like drawing commands. That's much less efficient than WebGL. Now we have context, the vertex source, the fragment source. And now let's use the program. And the thing that we want to do is we're going to draw something to the screen. Don't worry about this quite yet. I will explain everything in due time. So now if we go over and look at what we've got so far, you'll see, all right, we're getting errors. So the vertex shader is not compiled. So good. If we're having problems, then we will know about it. And why is it not compiling? Well, we haven't actually made them yet. So let's start with the vertex shader. And one thing that we'll need, so there's two different versions of WebGL. We want the newer one. And this is based on some old version of OpenGL that's, I don't know, like 15 years old at this point. So it's not exactly cutting edge, but it's still pretty great for what you can do on the web. So we want a point in space. And particularly we want a point in 2D space. So why do we have a four-dimensional vector here? Well, one, even if you're doing 3D stuff, even if you're doing 2D stuff, graphics accelerators are made for 3D stuff. So even when you're doing 2D graphics, you're doing it in 3D and you're just looking at a 2D view of it. So that explains why we would want 3D, but why 4D? This is using something called homogeneous coordinates, and this just lets you have all of your transformations be linear transformations. It makes it super easy to just do some matrix math and do stuff. So for example, translations you wouldn't be able to do if you only had 3 dimensions to work with. So that's our vertex shader. And what we're doing is we're just making a point at the origin. That's it. And this size, we're going to give the point a size. Otherwise, we won't be able to see it. So now the fragment shader is going to take that point, turn it into pixels. And again, we need this version at the top. This precision is something that you don't really need to worry about. You just need it for WebGL. And the way that fragment shaders work is you want the output to be the color of the pixel. So this is saying we are going to output a vec4 that is the color. And again, why vec4 here? This is because we have red, green, blue, and alpha, or transparency. So we're going to make a red, we're going to make this point red. And we want it to be opaque so that we can see it. Now let's take a look. And hey, we rendered a point to the screen using WebGL. And it might seem like a lot of work, but really it's not that bad. This thing is never going to change. You make this once and you'll get a lot of mileage out of it unless you want to start doing something really fancy. But this is it.